Good afternoon, everyone, and welcome to BOA202 Accelerate Modern Application Development with Serverless. My name is Minh Nguyen. I'm a prototype engineer at AWS. So my team helps our AWS customers to build rapid prototypes of innovative applications. And today I'm very excited to share with you all the model that I use every day at work, as well as some of my favorite tools. So in these short sessions, we'll quickly touch point on what really is a modern applications, why and how it requires you to your development practice to be different. Then we'll see how serverless approach can help you to address a lot of these points. And since the track we're on is called Build on AWS, right? We'll focus on a practical example where we build an applications with serverless services and tools. So first, what is a modern applications anyway? Or rather, why do we even need the terms such as modern applications, right? So at AWS, we define modern applications not as a particular technologies or an architectures, but rather like a list of goals or constraints that an application should meet in order to help the business to strive in modern circumstances. And these are the goals that you see in the screen that we find are the most important for business to thrive. That includes increasing staff productivity, business agility, operational resilience, as well as saving costs. Now, with years of experience supporting our customers to modernize their system, AWS has helped our customers to achieve tremendous improvement in these metrics. Like you can see in the screen, we help decrease in up to 90% time required for building a new applications with T-Mobile and Snap, or speeding up the time to market up to 3-fold with BrightStory, Depot, or strengthening system resiliency, availabilities, and securities. Some case study like Vanguard or Ancestry, and allowing up to 70% of cost saving with Coca-Cola and Samsung. Now, how did we do it and how you can achieve the same? Now, what we've found is that when it comes to modern application, there's a couple of characteristics that we found that ultimately will serve the goals that we're aiming for, which again, you can see in the screen are responsive in millisecond, fault tolerance, can scale quickly and effectively, modularly componented, and can be adaptive to frequent changes. But again, how do you get there? Now, obviously, there's not one way, but surely there's easier way than others. So what I will discuss with you today is the serverless approach, which, if you're unfamiliar, serverless computing is a cloud computing execution model in which machine learning resources will be allocated at runtime on demand, and customers don't have to think about infrastructure at all. Now, this might seem simple enough, right? But you see it's a powerful concept. Now, first of all, when you remove the need of managing servers out of the equation, you shift part of the responsibility for both scaling and fault tolerance to the cloud vendor, right? And at AWS, we're happy to take it for you because we have the experience and the economy of scale to run things efficiently. Now, simultaneously, when you cut down on cost and effort to run in the system, it is much easier for you to optimize your operations. But hey, we're here today as developers. And as developers, let's also focus on a different aspect, that serverless can also help you in the development process itself. How? Now, by allowing you and your team to have your laser focus on just the business logic, because everything else, like infrastructure, every mundane task is taken care of. Now, it can help you accelerate the time to develop and deploy change a lot faster. So, frequent changes. And second, as you will always also see today, thinking serverlessly can also help you to dissect the system into modules more easily and more intuitively. So let's see an example. Now, imagine you have a simple system use case such as order processing, right? You receive orders information from external party. Let's say the order data come in JSON files. Then you need to process it step by step, extracting the information from the order and storing them in a database. And then you might have a verification step to see if the payment is wire or the item in order is still in stock. And then you send someone to pick the order and fulfill the order. Now for receiving incoming data, we can use Amazon's simple storage service, S3, which allows for easy file receiving from any source. And as you can see, like different steps, one after the other. So let's use AWS step functions to orchestrate these components. And at data storage step, we use DynamoDB. It's a NoSQL serverless database to hold our ingested data. Next, for back-end processing, of course, we need compute resources. We run the compute on this system for verification step on Amazon Lambda, the serverless event-driven compute service. And to send the orders information to executor, we'll use Amazon's simple notification service, SNS, a fully managed pop-up service. So we can flexibly send the messages to a lot of receivers' needs. So let's see the demo. Okay. Now, first of all, let me show you the end stage. So like, what if the system is already built, what it will look like. So in the screen, you see a stack of application that has already been built, been finished. And these are the components that you just seen on the system we just discussed about, right? I have the input data in a S3 bucket right here. The orders data stored in a DynamoDB table. And you have order processing, which is the step function state machine. So this is my S3 bucket, DynamoDB table, step functions. And with step function, as you can see, the console itself also have a very nice visualizations of the workflow. So you can see what are the steps that should take place. And when you click to each of the implementations or executions, you can see detailed information like what's the input, output of each task, even like how long the task has been run for. So that's what we're gonna build today. So a little bit more, the source code that I'm gonna use today is located here. If you have your laptop and you want to also check out or walk through the code with me, feel free. And this is the sample of the input data. So imagine whatever source you have, the input data will be comprised into JSON file and it come into this format. So you have your typical orders information like customer ID, timestamp, item ID, quantity, and to make it fun, put a wait time there. So let's say each order needs to wait this amount of seconds before checking if the, let's say the payment has been wired. So how do we do that? Right, let's move here. So here I have my IDE on AWS Cloud9. So this is a cloud-based IDE on AWS. So it's really easy to use and you can share the cloud-based IDE with your partners for collaborations. So let's start the applications. Create a folder and let's initialize a application using AWS CDK. So CDK is short for Cloud Development Kit. This is the AWS Infrastructure as Code tool, which helps you to provision and manage all the infrastructures on the cloud, like the resources we have seen just now, just using code. And the language I use will be Python. All right, all done. What it do is create a CDK source code file right here with the app.py is the main endpoint. You also have the requirement here where you can define your dependency. I will change this dependency a little bit. And then you can install the dependency by saying pip install. All right. that should be it. That should be your requirement. Now let's get to our code, which is in the order stack right here. Right? So you remember the first step or the first component of the system we talked about, right? Which is an AWS S3 for saving inbound data file. So you create that by doing this. Sorry. That's it. Import the AWS S3 library, and then you say define an S3 bucket with that name. That's our S3 bucket. Pretty simple, right? Similarly, you can create a DynamoDB table the same way for storing our data, which is this one. Oh, sorry. Need to tap it. Yep. Again, say DynamoDB table, give it a name and give the partition key and the short key, which is required input parameters of the table. So at any point, we can actually deploy this stack, which means creating this whole infrastructures from what we code using, let's say, CDK deploy right here. So anytime you change the code at all, you can just run CDK deployed again, and all those changes can reflect onto your stack on AWS. Basically, it will create the input data and the order table, just like we see. All right, now let's move to our step functions, our workflow. So with step function, we actually have two components. Each of the tasks that the step function will execute and the step function workflow itself. So there's two import there. And our first task is to put information into DynamoDB table, right? So basically you have the put info task, which is a DynamoDB put item task, where you say, get the information from the inbound package and save it into DynamoDB table with this key. So the key is customer ID, and the data is get the customer ID from our input package. Similarly for all other things. Now, another thing is you may have noticed that the inbound data that I have multiple items in them. So we want to do parallelization. So each order is processed individually, right? Doesn't have to depend on each other. So how we do it with step function is pretty simple, which is you create a process items variable and say it's a map, and do an iterator on put info. And to wrap it all up, we create a workflow items or a state machine, a step function state machine, and define the step as get the process items. And once you run through the process item, the next state is a succeed state. Now, another note here, the final line there, as you can see, is because with AWS, everything is secure by default. So you have to explicitly allow a resource to be able to access the other resource. So in this case, I have to grant the workflow the permissions to read and write to the DynamoDB table. So we have our input data in S3. We have the target of saving it into a DynamoDB table. We have the step function task to write it in. So what's missing here? Any guess? We're missing the link between the S3 and the step function, right? So how do we say that every time there is a new file that comes in S3, let's trigger this this step function and pass in the content of that file? And that's where we will create notifications functions or Lambda functions. And the way we do that, so we create a Lambda function very similarly by creating this one right here. Say a trigger Lambda. So the main thing here is the code itself, right? What code go into your Lambda executions. And we say that get the code from a folder called Lambda functions trigger and call a file named index and get the function named handler from that index. We haven't created yet, we'll create it in a minute. So what we also want to do is set the notification or S3 notification. Like here, and say to the bucket, that whenever there's a new event of object created, call that trigger Lambda functions. So that's basically it. Every time there's a new S3 bucket, S3 object going in, it will call that Lambda functions. So now let's create that Lambda functions, right? Again, what I define is that CD. And touch. All right, now we have our intended file where we should put our code to the Lambda function in. Now, what do we do in these functions? Basically, read the data from the file, right? Read the data from the file and start a new executions of the state machine, the workflow that we just created with the content of the files as the input. So that's it. But how do we get the content of a files from the notifications itself? I'll introduce a tool which is very helpful for accelerating your development process, which is AWS Lambda Power Tools. So Lambda Power Tool is not particularly a tool, but it's a set of libraries to help you standardize all the tasks that you need to, not all, but a lot of the tasks that you need to do in your Lambda function or serverless development. So one of the such tasks, let me just import Power Tool first. So the import of Power Tool is, again, pretty simple, which is you define it at a Lambda layer. Let me define it here. Looks like this. So create a Lambda layer from the versions that is already created by AWS. And then in your function, say layers equal Power Tool. That's it. That's our Power Tool import. And then this is how you can call it out. Okay. So basically, we import the Lambda Power Tool data class, and we parse the event source into that data class, so that later on, what we can do is this. So let's say now we have the record parts. We can just say record.s3.getObject.key. So it's handle all of the data structure parsing for you. Right. Another tool, just an example of another tools that Lambda Power Tool can help you is a logger. Everyone needs a logger, right? It's also very simple. Just define the logger like this, and then you can log any information we want at all down below. All right, so that's the first two steps, right? Get the data, save it in the DynamoDB. Now, do we do next? The validation step, right? Remember the fun thing that I talked about where the system have to wait a little bit, and the wait time is defined in the inbound package itself. And then after the wait time, it needs to go to check whether let's say the payment has been done yet. So let's do the wait first, which is right here. Do this. Yeah, this is how you do the wait. Just step function wait, and the wait time is defined by an inbound path that we define there. Again, let's do our validations Lambda functions. Which is, again, just Lambda functions define our code path, say that we will also use the layer power tools, create a Lambda invoke task that call that Lambda functions we just created, and say, after the wait, call the validate. So wait.net validate, right? Do a little bit more of security here. And also, let's define our Lambda function. Sorry, wrong one. Let's go into our validate functions and do something like this. So I created some mock API for payment check. So let's say we have two payment, one to check for two endpoint, one to check for payment and one to check for whether the items are still in stock. So this is how you can see we can integrate with any external API at all. And what you can also see is that the output, we want it to be in a particular format, right? We want it to be result something and status code something. Now, how do we enforce that? Well, I'm glad you asked, or I'm glad I asked, is that we can use also Lambda power tools. It also have some libraries for validators. And the way you define the validators, again, is a decorations on top of the handler. Pretty simple, say output require result and status code, the type of the result and status code variables, and say validator outbound schema equal output. This way you can define any data structures you want to enforce at all, both for inbound and outbound of your data. So similarly, we can do our notifications to send notifications to our humans fulfillment the same way. So after validation step, you can say create an SNS, simple notification service topic, and subscribe to that topic an email subscription, that's my email, an SMS subscription, that is my phone number, and say, yeah, send this message to the two subscriber here. And SNS allows you to do a lot of type of subscriptions. So it can be human, like email and SMS, but it can also be like, machine, like another Lambda functions or an HTTP endpoint. And then you say, if the validation is successful, when we return true, then call the send message, otherwise just don't call it, just say it's a failure. And so we say confirm and then validate.net.confirm. So you see, this is how we define the whole applications in, let's say, less than 100 lines of code. Again, if you want to deploy this whole thing, just run back from the root folder cdk.deploy. And then you have the applications that we have from the start. So, all right, let's recap. Sorry. Okay, so we built a simple, but I hope you agree that it's pretty extensible serverless applications to process order or process any data at all by ingesting data into S3, then use S3 notification mechanism, which is backed by Amazon Event Bridge, to call a step function workflow where we use Lambda for backend processing, SNS for notifications, and DynamoDB for storing data. In the process, we also use AWS CDK for infrastructure as code, Lambda Power Tool for helping with a lot of the standardized libraries, and AWS Cloud 9 for IDE. Now, as you can see, again, it takes just under 100 lines of code to build such applications. So any change, as you can imagine, can be quickly typed into the source code and deployed using CDK deploy. So frequent changes. Hope that you also agree that it's modular. So we think about each step, each task as its own modules, and sometimes use its own service. So we can kind of dissect the system that way. Meanwhile, it's also highly scalable because as you can see, we parallel line is in the process. So whether you run one file or one order or 1,000 order, it doesn't matter, it still run the same. So it's a small system, it's a large system, you don't have to re-architect it. Fault tolerance is built in by default into a lot of our serverless services and respond in milliseconds. So to expand a little more about the modular native of the applications, now you've seen how it's constructed. Hopefully you can see that it's very easy to just add in more module into the whole workflow pipeline using other serverless services like comprehend, or add another external API call with Amazon location service, or from the saved data, do data analytics or business intelligence with like QuickSign or Athena. So to recap again, some takeaways I'd like to send your way is modern applications require different approaches. So in order to meet these characteristics, maybe it's not about the hottest programming language or the latest framework, but rather it's about building application differently or changing your approach to be a more modular, a more scalable, a more responsive, a more secure, and a faster way. And serverless can help you to do a lot of that. Aside from the great operational benefit, serverless can also help to elevate thinking about application development, reducing your time and effort spending on development, and allow you to focus only on your system problem, and allow you to develop one and scale for any scale. And third, when it comes to development acceleration, using the right tools make a bit different. So if anything, I hope that after today, you'll be able to use these three tools for your advantages. Again, in summary, modern applications require different approach. Serverless help you to accelerate developments, and using the right tools matter. So that's all. And if you want to dive deeper into serverless and building on AWS, you can check out these sections that is coming up next, especially the first session, which will come right after this one. And check out the Skill Builders AWS Online Training and Certification Center to explore more than 600 free digital courses, hand-on labs, and role-based games. Also, okay, thank you very much for joining me in this session. So if you found this helpful, please leave your feedback in the sessions. Or if you have any questions, you can also leave them in the feedback. Thank you very much. Once again, I'm Minh Nguyen from AWS Prototyping. Thank you very much.